one final frontier for us retro fans, and that is reading native Amiga disks on a standard PC or an emulator like WinUAE. And until now, there was no way to do this. You had ADF files and you had these copy protected files in a special format that wasn't track-based. And now someone cracked the code. He used a mini Arduino, a USB to serial adapter, and a super standard 3.5-inch PC drive, some cabling, and a 5-volt power supply. So let's see if this thing really works. So let's talk materials. First of all, and maybe the centerpiece of all this, is a standard 3.5-inch PC floppy drive. You can use probably any brand. I'm using an Alps electric model here, which is one of the brands of the original Amiga. We need some kind of cabling to interface with a floppy drive to provide it with the 5 volts, which is the red line, and one of the black is the ground line. 5-volt power supply, so we will have to manage to plug this together somehow. We have a USB cable, I guess this is mini USB, and we have a standard USB cable, which you may know from your printer. And you may notice there's nothing here where this plugs in. This is because you can do this project with 3 different types of Arduinos. So the heart of that project, besides from the 3.5-inch floppy drive, is a software written by Rob Smith, and that software has to be uploaded to the Arduino, and there are 3 different models which are supported. The one I have right here is, as you can see, the Arduino Nano, which has the, I guess, USB mini plug. To load software onto this, you plug this into your PC, you use the Arduino IDE, which I will show later, and you can upload the software from Rob right onto this little Arduino microcontroller. But there are different kinds of microcontrollers, and I actually built this thing 2 times now. The first model I used was, let me see, this right here, which is the Arduino Mini Pro, or some Chinese variant of it, which has the very important feature that you can just pretty much plug this serial adapter, which is needed to interface with the floppy disk drive, directly into this board. If you check here, this does not fit here. You have to wire this by hand to the RxD TX1 ground, and can use it this way. So I did actually build this one then, and that is a very important thing to know. I tried it, I chatted with Rob on his Discord channel, and found out that I had the wrong model. So I had actually an Arduino Mini Pro, but it does come in 2 variants. There's an 8 MHz variant and a 16 MHz variant, and by chance I ordered the wrong one, the 8 MHz variant. So you need the 16 MHz variant because this serial connection needs a 2 million baud data transfer rate, and the 8 MHz model only provides up to 1 million baud. So this is too slow to interface with the 3.5 inch floppy drive. And so I actually built another one with the Arduino Uno, and this specific model does need this kind of USB plug to program it. So you can't program it over the serial port, you have to program it with this cable over the Arduino, and then you use the micro USB cable to actually put it into the computer and use the disk drive. So this cable is only used for the Arduino Uno variant and the programming of that one. Okay, with that out of the way, we have lots of cable. We actually need about, I guess, 15 or 16 cables to do this, and a 1 kilo ohm resistor, which goes here, which does pull up the 5 volts on one of these connectors. And this is it. So it's not a very complicated project to do, thanks to Rob's ingenious design. And as I said, the main stuff happens in software, in the sketch file, which is uploaded to the Arduino. So we'll get to that later. I guess it's time to build. So let's build this thing. I guess it's called the Floppy Bridge, Amiga Floppy Bridge. So let's go. You do, of course, need some kind of floppy cable to connect the disk drive to the Arduino, whichever model you will use. Just notice that you do not use the twisted connector. You need a straight floppy cable. If you don't have a floppy cable, you can actually use this kind of connection and plug it directly into the interface. So these small cables, which you can use, you can, for example, use a double-sided one of these and one of these, plug this in here, plug this side onto the floppy connector and this side into the Arduino. This is one way to do this completely without soldering, at least on the Arduino Uno, which has this connector side. So the first thing to do is to connect the Arduino and the serial to USB interface, because, as I already said, the magic of this project lies in software. So in order to program this Arduino Micro Pro, we have to actually connect it to the serial bus and use this serial bus, this serial connector, to connect it via USB to the PC and program it using the Arduino IDE. And you simply plug the serial USB adapter into the Arduino Micro Pro or Mini Pro and solder it on. You just have to bend up one pin. That's the second pin from the right. You have to bend this up before soldering it in. So there are 6 pins and you just solder 5. So there you have it. The Arduino Mini Pro connected to the USB to serial interface. This way this whole thing is programmed, because this Arduino Mini Pro itself doesn't have any kind of USB connection. And using the ports on the side, the GPIO pins, you connect the floppy cable to the Arduino and the floppy drive and use the external power supply, and so all of this will work, hopefully. One more thing, there's a switch between 3.3 and 5 volts on this little red serial to USB adapter board. Make sure that you're setting this to 5 volts, because we're working with 5 volts here. So I'm using my Windows PC here, and in order to program the Arduino, we have to first install a serial driver for the serial to USB adapter. And in order to do this, we head straight to the driver website, which I will link in the video description. On this website, we scroll down to the Windows driver section, and this is the thing where you select the 32-bit or 64-bit version. I'm using Windows 10 in the 64-bit version. I guess there's only one really. And after the package is downloaded, you just double click, wait for Google to check the file or whatever browser you use, and that should pop up, and you execute the executable. Yes, we do. And you simply hit next or whatever, next, and yep. And it's copying away, and that's pretty much it. Driver installed. So after plugging the Arduino into my Windows PC, it's blinking away, which I guess means success. Let's see if this thing is programmable. So we head over to the device manager in Windows and check the COM and LPT section, and there we find a COM3 port which was just installed. This may be a different port on your computer, and you have to remember this to use this in ROP software later. So for the next part in our software stack, we head over to the Arduino website and download the Arduino IDE, which stands for Integrated Development Environment, in which we can upload the software that Rob provided to the Arduino. And here we select the Windows Win 7 and newer version, and if you like you can contribute or just download, and the download starts and we run the setup and we just install everything offered, and after that we are asked for some drivers to install, which we want to do too. So install, and install, and that's the Arduino IDE. As a final step in our software download journey, we head over to Rob's website and download the ADF Reader Writer 2.5, which provides us with the sketch we have to upload onto the Arduino, as well as the reader writer software, which we can create ADFs and other files from disks. We create a folder on the desktop and simply unpack everything provided in the zip file. So finally we get to the part where we actually upload Rob's software to the Arduino. And for that we start the Arduino IDE. Right here my file is already loaded, but I will open it again. File, open, go to the folder you just unzipped all your stuff in, and select the sketch folder and open the floppy drive controller sketch IO. And then we have to select the right Arduino board, which is the Arduino Pro or Pro Mini, and the Atmega 328P 5 volts 16 MHz, which is very, very important. And the COM port you installed your serial driver at, which is COM3 in my case. And then we had to sketch, upload, and we get some debug information, which is okay. And the file is uploading. And this takes a while, and then it shows upload complete. And with that, our Arduino is programmed with Rob software. It's a very small program, but Arduinos tend to have very limited memory, so this is totally normal. And you can now leave the IDE, and we will start building the actual hardware interface between the Arduino and the floppy drive. So for the wiring, my idea was actually not to kill a floppy cable. I would go on and put one side of the floppy cable into the floppy, just as you would expect, and I wouldn't cut the connector on the other side of the cable. Instead, I would use some breadboard wires to just plug into the connector. And this way I could save the floppy cable, and if there would be any errors, I could simply unplug and replug them in the correct position. So all that's left is to start soldering. That's when I realized that one cable had to be split to connect to 2 pins on the floppy disk drive connector. And so I just went on and cut some cables and soldered some cables, and on we go. All that was missing now was to put the 1 kilo ohm resistor on the 5 volts line. So after checking and rechecking and more checking and all the cables, connections and whatever there was, I was ready for some serious testing. So from the previously unzipped software package directory, I started the Arduino floppy reader writer, selected the right COM port and tried to test my construction. And you're warned that you have to insert a disk which you don't mind being erased, which is okay for me. And that took a while. And another one. Getting nervous here. After a few more seconds, diagnostics finally failed. After searching for half an hour to find the error and finding nothing, checking the wiring and rechecking the wiring and reprogramming the Arduino, I finally headed over to Rob's Discord server, and Rob helped me out with some diagnostics tips, and I finally found out that I had the wrong Arduino Mini Pro. I bought the 6 MHz version, which, as I already told you in the intro of this video, is the wrong one. So after a few hours of being really pissed, I remembered to have another Arduino, Arduino Uno, grabbed that one and quickly wired up without even soldering this version you can see right here. And that worked first try. So all I needed now was a proper case. So I guess it's time for some testing, and for that we again go to the Amiga Floppy folder and start the Arduino Floppy Reader win.exe, which was provided by Rob, and we check that we have the right COM port selected, because all the communication is done via this little USB to serial adapter on the Arduino. We select the kind of file we want to save, and we just say Workbench 3, and I did put my copy of Workbench in the drive, and away we go. And the cool thing is you can even copy protected disks if you switch from ADF to SCP. And as you can see, this time it reads the disk perfectly. And you can see up here where the ADF file is saved. And next we will take this ADF file and try to use it in WinUAE. And we start WinUAE, and this is a beta preview Rob provided, which can actually read disks directly into the system without saving them as ADF before. But we're trying the ADF way now, and there will be a separate video where I show all the things you can do inside WinUAE to actually connect the drive directly, which goes via the expansions, and then there's a new category disk controllers, and there you can select the Arduino reader writer. You have to enable this, and that's pretty much it. You can use this as DF0, but we don't want to do this now. We use the standard IDE controller, even though we don't use a hard disk. But we will now go and select our freshly WB3 ADF, which we just created. Hit start. That's not good. Oh, here we are. Just took a moment. And as you will see, this thing. Oh wait. It's actually reading from the drive. So this was unexpected. But I guess here we go. We just loaded Workbench from an actual disk using a PC disk drive. That's pretty awesome. So let's see if we can get in here and find out why this happened. I have disk controllers. So I guess if we uncheck enabled, this is still in here. Okay. So now it's actually using the ADF file. So if you disable or uncheck enable on the disk controller, you actually switch to the software DF0, and if you enable the controller, you actually use the real drive, which is pretty amazing. So here we are from the ADF file we just created. wow, I'm impressed. Okay, so I guess this pretty much wraps up this video. And so I also covered the WinUAE stuff. Nice. Okay, I hope this was interesting, and if you feel like it, try to build it yourself. It's, as I said, not too hard, and hope to see you next time. If you have any questions, just leave me a comment and I will gladly help. And there's also a Discord server which is hosted by Rob, and there's already a very active community which helps in building and software troubleshooting, so head over there and if you need any help. So until next time, bye bye.